All right, let's talk about constructing and interpreting these things called scatter plots. We'll define what those are in a second. We're going to find patterns with these scatter plots. We're going to be talking about something called correlation, whether it's positive or negative. And then we're going to talk about clusters and outliers. But before we do that, let's figure out what a scatter plot actually is. So a scatter plot shows the relationship between two variables. You're going to see a graph that's on a coordinate plane. It's going to have a whole bunch of dots there that show the relationship between the two variables. To make this real, let's look at a specific example. Here we have Ramon is a scientist studying the population change of a type of bacteria at different temperatures. So when the temperature is 1 degree, what is the bacteria's change in population? And when it's 10 degrees, what is the change in population? When it's negative 10 degrees, what is the change in population? And Ramon might get all sorts of different results. We didn't actually do this experiment, but let's look at some of the kinds of results that he could have gotten. So first let's look at an example of a linear association. So I know this graph is a little bit small, but really quickly let's just look at it. It's a normal coordinate plane with x and y, and we have all four quadrants, so we have negative and positive values. And you can see all these little dots here. Each one of those is a data point. So there was some temperature, that's x, and then some change in the population, that's y, and you would plot that point. And then you do the experiment again at a different temperature and you plot that point. And you can see in this case, the points are all kind of lining up really nicely in kind of a straight line shape. So we call that a linear association. It's a straight line. Now, the data don't always line up in a straight shape like that. They could also have a nonlinear association where there's still a pattern. Clearly, these dots are following a pattern. It's more of a curve. Probably it looks like an exponential pattern. But it's definitely not linear, right? So we call this a nonlinear association. And a lot of times, the data don't have, when you look at it, they don't really have any sort of apparent strong association, linear or nonlinear. They look something like this. And this is where the scatter plot gets its name. So a whole bunch of dots scattered all over, plotted on the coordinate plane. And we use statistics to try to figure out if there really is a pattern here. Here you can't see very much of a pattern, although there's not too many dots down here. There's not too many dots up here, so there is something like a linear or nonlinear association, but it might be kind of mild. But it's certainly not very strong, so we would call that no apparent strong association. Okay, so that's some of the patterns. Now let's talk about positive or negative correlation. So let's say that Ramon got a graph that looks like this. We would call this a positive correlation. The reason we do is because as x increases, y also increases. As x decreases, y also decreases. They do the same thing. So as the temperature goes up, the population change increases, is what a positive correlation is for Ramon. More generally, when x increases, y also increases, and that's called a positive correlation. Can you imagine what a negative correlation might look like? Yeah, you would have when x is increasing, y is decreasing. So here's x getting bigger, and then the points are getting smaller as far as their y value. So that's a negative correlation. In this case, as the temperature goes up, the population change decreases. Or in other words, when x increases, y decreases. That's what a negative correlation is. So Ramon might get any sort of results that look like linear, nonlinear, positive, or negative correlation. There's also a few other things to look for, like clusters and outliers. Let's look at another example of what Ramon might get. Now this graph looks kind of similar to what we've seen on the left-hand side. What can we say about it? Well, it seems like there's a linear association, at least for most of the points, seem to be on a straight line here, right? There's some exceptions out here we'll talk about in just a second. What about correlation? Is this positive or negative correlation? Yeah. These are negatively correlated. As x is getting bigger, most of the data points are getting smaller. Most of the y values are getting smaller. Now, what about these two interesting points out there? We're going to call those outliers. There's two of them, one in the upper right and one in the lower left. And probably if Ramon got that kind of a result, he would want to look into those outliers to understand if anything else was going on that was telling us something interesting about why those outliers were there. And then can you notice anything else about this graph and the dots in the scatter plot that is interesting? Yeah, we're noticing something down here where there's more points down here on this part of the linear association than there are up here. So what does that mean? Well, we don't quite know, but we should definitely note it. We'll go ahead and write that there are more points clustered in the lower right. And that would also be something that Ramon would want to look into as he's figuring out what his data means.